In that sequence you've seen me throw something together really quite quickly. I've got a very simple tray made up of a piece of scrap MDF, and this material you saw me chopping up, this was part of the packaging that the laser cutter came in. So if I just take this to bits, hopefully we'll get an idea of what I'm thinking here. This really is why a laser cutter is such a great machine to have, because you have an idea and you can implement it really very quickly indeed. So what have I made? Well, very simply, I've got a collection of model railway track building tools here. These of course could be any kind of tool that you can imagine. And I like to look after them. So why not give them their own little case? There we go, quick project, super simple, looks great. What I will do off camera probably is make a lid for this, which will sit over this edge. I'll engrave, say what's in it, put some of those little silica gel things in to try and keep the moisture at bay, and there we go, stick that on the shelf, job done. Hi, welcome back to Bexhill West. I'm James, thank you for joining me. So today's video is a part 2 of a first look at the Creality Falcon2 Pro 60 watt laser cutting machine. And I had promised that in this video we would use the machine to kind of, in a real world situation, and build a project. Now I've got the project behind me. You have seen, I think regular viewers would have seen a kind of a pre-prototype of this a few weeks ago. Anyway, I've been busily working away with it, but I've been rather taken aback by the power of the 60 watt machine. It simply cuts through all the normal materials I use so quickly that I'm actually having to spend quite a bit of time recalibrating my head around the settings required to get that machine working at its kind of to its optimum. And really that's why this project isn't yet finished, I'm afraid. And being keen to get another video out, I thought what I'd do is run through some of those settings or those the tests that I've been doing over the last week or so, kind of dialing in the settings for the machine. Now, one thing I've become astounded by is just how fast it will cut through regular materials like we might use with our model making on the 60 watt setting. And I've seen comments online where people say that, oh, you know, that's too much power, you're going to burn up the material, it's, you know, you're better off using a lower power setting. So I thought, well, let's put that to the test. So I run a series of tests of the different power settings. I experiment with the full 60 watts but dialed down in software, and I specifically look to see whether or not there is any negligible effects to the quality of the cut. And something that's quite interesting is the kerf width, or the width of the laser beam. I won't spoil the video by telling you what's what now. You could probably guess the outcome, but it's interesting to test it and kind of get some real world evidence. Anyway, although this isn't finished, I will bring you in closely to have a look at this and some of the parts that are effectively going to create the kit enabling me to build this thing. This is kind of like my pre-prototype, so I will get this made, and it will probably be in the next video now, and we'll get this done. But I'll bring you in closely and look at the quality of some of the bits and pieces that the machine's been cutting. So then, this is the model that will be part of that video where we show the machine in action. It's a station building. If I remove this part of the canopy, everything on here has been laser cut. Now this is, as I said before, this is a kind of a pre-prototype. I'm just putting together to work everything out. But if we take a look inside, let's find somewhere to put this. Let's have a little look at it. All the brickwork detail has been engraved. We've got quite fine windows. I think I can make those finer still. Taking a look inside, excuse the quality of the paint job here, this really is still a work in progress. If we have a look on this side first of all, and pop one of the window units out. The window frames are held in a little rebate into the walls, which obviously leaves a bit of an ugly finish around the inside. So there is an overlay which kind of boxes that in so that the frames are properly set within the brickwork. A similar sort of thing going on here. We've got rebates created that the windows can fit into, and then they will be properly set in when the stone surrounds are on. So I didn't think this would take me as long as it has to figure out, and it's all fine. I've run into a slight snag with it, and this is one of the reasons why I spent a bit more time experimenting. I tried to use my usual brick painting technique, and I hope this shows on the camera. The quality of the engraving of the brick pattern is superb, but the kerf width of the laser is so thin that it's not giving me the desired finish I want with all the mortar joints. So that's one of the reasons why I've been experimenting with the laser a little bit. Anyway, I've got all those settings dialed in now, so I can go ahead and do the final build, which, as I say, should be in our next video. As for materials, well, quite straightforward. I've used a laser grade MDF for all of the walls, and you can see the brickwork detail. Flemish bond if you're interested. So I've got several sheets of drawing work for the various wall elements. The window frames are all produced using stencil card, so it gives you an idea of sort of what's involved with those. And look at how fine the laser kerf line is. It's really excellent, and they cut out and assemble together, laminate up to create, if we bring you in and have a look here, the correct sort of sash window detail. The windows look like they will actually slide vertically up and down. And then we've got some laser board here, and you can see these are the overlays that I fitted inside the building. My ambition is that we'll be able to get a camera sort of through the window or through the door, and the interior will hopefully look as nice as the exterior. There's even a parquet floor, but I've not polished that yet. Anyway, that's all to come in a future video. Let's get on with doing these laser tests, which is the subject of today's video. But whilst we're here at the workbench, I will mention just quickly, it's got nothing to do with this particular video. You saw me 2 or 3 videos ago put these little hopper wagons together, and I said there'd be a part 2 and I'd finish them off, and there is going to be. Somebody had commented or asked the question whether they could be made to be sprung, so I've sort of spent a bit of time experimenting, and we've now got a sprung version of the hopper wagon, and we can take a little look at that in a future video. In fact, so much so that I've been making all of my 3D prints sprung. Anyway, that's not what today's video is about. Let's get on with it. This little box you've just seen me put together, it relies on sort of like finger joints, and it relies on great precision on those finger joints because there's no glue on this at the moment. I've literally just put it together, and it's such a tight fit. I think I'm going to struggle to get it apart, but I will do eventually, and I will glue it. But the secret to getting really good quality, accurate joints and sort of mating pieces is to have a good understanding of what happens when the laser cuts. So there's a number of basic tests we could do. So what I thought I'd do for this video is run some of those basic tests. So let's get this out of the way. And here's 3 of the most basic tests. We've got 22 watts, 40 watts and 60 watts. So if you recall the Creality Falcon2 Pro 60 watt machine, we can dial down the settings on it. So we could choose a precise setting, which is equivalent to 22 watts, the normal setting, which is 40 watts, and the powerful, which is 60 watts. What these tests aim to do is to run the machine at different power increments. So in this case we're going from 10% up to 100%, and at different speeds. And really what this tells us is a couple of things. Firstly, we can see how fast we could cut a particular piece of material. So this is 3mm plywood, and here at 720mm per minute at 100% power it's cut through. That doesn't mean that's the optimum cutting speed, but it means that's what it will achieve on this piece of material. If you inspect the cut edges a bit more closely, it may well be, and very often is, there's a setting somewhere else on this matrix where we get a cleaner cut. Anyway, that's the basic tests for 22, 40 and 60. Now, because of the different power ranges, I've changed the scale on each of these up the left hand side. So whereas we were still cutting 100% power at 720mm per minute of 40 watts, at 22 watts, on the 40 watt one that's 1030. That's the setting I've got there. I think it possibly would go a little bit higher. And then at 60 watts, again at 100% power, well here this was 1600mm per minute and it's still cut. I probably should have extended this scale slightly further. But let's bring this a bit closer and focus it in and see if we can draw some other conclusions. Okay, so hopefully you could see that we've got some overburn on the surface, some discoloration on the surface where the power and the speed settings aren't really optimized. So I like to run a series of other tests to try and find optimal settings that are going to give me very, very clean surface finishes. So here are the results of some other tests I've done. Again, 22 watts, 40 watts and 60 watts. So precise, normal and powerful settings on the laser head unit. And this time round, and I've repeated these tests lots of times, I've tried to find an optimum, something that will give me a really clean cut, really clean finish here, but also leave the surfaces of the material really clean, no sort of overburn or extra marking on there. So for 22 watts in this 3mm plywood, I've got 700mm per minute at 100% power. For the 40 watts it was 1100mm per minute at 100% power, and for the 60 watts it's 1450mm per minute at 100% power. If we were to compare the finishes here, they're identical. So I'm not suggesting that it's optimal to be cutting at 100% power. It's not necessary. All I'm doing here is trying to see how can I get a really good quality cut finish in a single pass, and what sort of speeds are involved at the different power settings. A kind of comparison, if you like. What I also did was measured these up and calculated the kerf. Now I won't run through how I did that. There's a really excellent video online. I'll leave a link in the description that will show you how to calculate the kerf. But at 700mm per minute with the 22 watt setting, we had a kerf of 0.078mm, so let's call that 0.08. The 40 watts 0.09, it was actually 0.085, and the 60 watts it's about 0.11. Let's call that 0.1. So clearly then we have a narrower kerf at the lower power, steadily getting wider up to the maximum power of 60 watts. No surprise there. I think probably we could have all guessed that, but it's interesting to measure it and see what's what. Now I posted these results online and I was asked the question, what would happen if we use the software to dial the 60 watts back? So what if we ran this setting, 60 watts, but instead of 100% power, what if we went, say, 33% power, so it was broadly equivalent to here? Would we see the kerf setting be the same? Would it cut at the same speed? Just interesting. Would we get the same surface finish? So I thought that would be a really interesting thing to test out. So then, stepping over to Lightburn, I can show you what this next test is going to entail. I've got 3 squares, each of these are 50 by 50 millimeters. If I select one of them, there we go, up here in the screen we can see their width and their height. I simply drew one and duplicated it to create 3. I've given each one a different colour, so we've got black, blue and red, and I'm going to cut these on the powerful setting, so that's all 3 LEDs illuminated up here. So we're putting a notional 60 watts straight through the lens. Okay, if we have a look at the cuts and layers tab on the left hand side of the screen, you'll see that I've adjusted the speed and the power to be broadly equivalent to those 3 test pieces that I showed you earlier. So I'm running 1450 millimeters per minute at 100% power, that's our 60 watts. I've knocked it down to 66.6%, so that's going to be hopefully equivalent to 40 watts. And I've put the same cut speed in here of 1100 millimeters per minute that I used on that other sample earlier. And I've repeated the same thing with the 700 millimeters per minute and reduced the 60 to a third, so that's going to give us like a notional 20 watts, not quite the 22, but you know, it's probably going to be near enough. So what I'm going to do is run those pieces and I will measure them up and we'll see what the kerf speed is like and see if there's any difference in the cuts, the quality of the cuts, running sort of 60 watts at lower power versus 22 or 40 watts at 100% power. So that's the plan. Now to do which, if I click the camera icon, that gives us a view of the machine. I'm just going to push the laser head out of the way. Let's take another picture. There we go, you can see the piece of material. So if I select those 3 pieces, I can kind of fit them in there. Okay, that looks pretty good to me. What I'm going to do is frame the job just to check, or in fact I'm going to home the laser first, hit frame, and that will give me a visual indication that we're more or less in the right ballpark. And of course I haven't selected the items I want to frame, so there we go, click frame. Okay, that's what I expected. Let's run the job. So I'll close the cover and hit start. Now I've opened the cover and stopped the extractor fan. You can see there's still some residual smoke in here, but hopefully you saw that whilst that cut was in progress there was a lot of smoke generated, but none of it escaped this enclosure. The exhaust system on here is brilliant. Okay, what I'm going to do then is I'll turn the camera off, I'll get these bits out. In fact, let's mark these up first. So let's call this number 1, number 2, number 3, and we get those out and have a look, see how the job is done. Now, quick spoiler alert, these are the 3 parts you just saw me cutting, and you can see 1, 2, 3, they're the numbers I wrote on there. Slight problem, they didn't cut out. So I've repeated this test many times, reducing the speed settings until I get them to cut out. I'll cut into the rest of it, we'll sort of cut to the chase with the final settings now, but just to explain, the final pieces that you see me showing are not the ones you just saw being cut, although the process was the same, albeit the speed dialed down. So to remind ourselves, these were the first test pieces I cut. We've got the 60 watt, 40 watts and 22 watts, and what I was trying to do with those cuts wasn't necessarily to find out how fast they were cut, but to try and get a comparable quality of finish along the edges. So you can see these walk up from the same piece of material, and I can't tell the difference looking at the edges of the material there between the quality of the cuts. Now it just so happens that we had a speed for 22 watts of 700 millimeters a minute, 1100 at 40 watts and 1450 at 60 watts. So I immediately thought, well, let's repeat those figures on a separate set of test pieces, and if I find the first attempt, when I did that they just didn't cut out. So these tests were cut by dialing down the 60 watts. And I've done lots of tests, got some of the scraps here, and I've finally settled at these values as giving me broadly similar sort of cut finishes on the side. There's no point cutting something really quickly or really slowly if the quality of the edge is not going to be perfect. So if I lay these down, and I've engraved the values that I've used on here. So I've got those the wrong way around. There we go. So this was 60 watts dialed down to 33% full power, so not quite 22 watts, but let's say, you know, a third of 60 is 20 watts, and that's what we got. That's what we got at 66 or 66.6 actually, and that was at a speed of 700, and again 100% it's 1400. So I would expect the cut speed to match what I had here, but when I tried it at 1450 I got a few little wispy bits. So let's accept that because these were from two different pieces of material that there's likely to be some variation, but I experimented with those settings, as I say, to give me a consistent cut finish. So what can we draw from, what conclusion can we draw from this little test? Well, quite frankly, if we use the full 60 watts and we dial it back to have the similar sort of power to the 22 watts, we're having to cut slower. And I think that is probably because we're running through more prisms within the laser head, that there's a bit of efficiency loss through the optics of the machine. So if we wanted to cut something at 22 watts, we would be better to use the 22 watt setting. If we wanted to cut a material that really we chose, you know, about 40 watts would be about right, it would be better to do it with the 40 watt setting. It would be quicker. Doesn't really make any difference, although this one is 50 millimeters a minute slower than this one. As I say, I think that's probably due to the material rather than, you know, any other shenanigans going on. But it does beg the question, if you've got 60 watts, why would you cut it slower? Because I can't tell the difference. So clearly then, having more power does give us a faster top speed, a faster cutting speed, which is useful, and there doesn't seem to be any depreciation in the quality of the cut depending on which power setting we use. Very quickly, let's compare. So it's 3mm material, 22 watts and cut 60 watts dialed down. If I put those side to side, I really can't tell the difference. I'm not sure how the camera, you know, is going to pick this up, but I definitely can't tell the difference with my eyes. We could say the same for 40 watts and the same there at 60 watts. And what I've used to derive these settings that I've chosen is what settings give me a nice clean surface finish. So if we look at this one that was a failure, it didn't penetrate all the way through, we can see this overburn where we've clearly got too much power going into the material. Here I've set the speed to match the power to give us the cleanest possible cut. Coming now to our test pieces where we've cut at full 60 watts power but just sort of dialed the power back in light burn. It'd be interesting to see if the kerf settings are the same as running at 60 watts or whether the kerf narrows. Now I think I know the answer to this one, but let's do a quick comparative test. So I've done the maths, and cutting at on the powerful setting, which on the Creality machine is 60 watts. So cutting at 60 watts but 33% power, we get a kerf of 0.17. At 66% it's 0.11, and at full power I've got a kerf of 0.12, which varies from this one here. This was 0.11 down to 0.12. It's kind of by the time you've done the calculations and you've divided things and whatever, these numbers are essentially the same. So what have we learned? Well, probably nothing that we didn't already know, in as much as the kerf when cutting at 60 watts, regardless of the power, stays pretty consistent. And I guess that's because the kerf is defined by the optics in the laser head. So this really gets to the bottom of why being able to switch between the power modes is useful. If we only need to cut something using 22 watts and we need precision, dialing the machine down will give us a much tighter kerf. If, however, we want to cut more quickly, we can run the same thing at a faster speed. Now we're looking at the difference here of 0.078 and 0.1, maybe 0.11. There's really not much in it at all, and there'll probably be very few users who would appreciate that difference in kerf of tenths, maybe hundredths of a millimetre, but you never know. Now the next up, and I've no idea if this is going to work at all, somebody asked, will the machine do brass? I very much doubt it's going to cut the brass. It might engrave it. Now I'm not going to use much of this brass because I've actually got this for a different project, but I think we can afford to sacrifice a little slither off the side just to have a little play. So I'm going to try, well, let's try engraving Bexhill West along the side of this piece of material, and we'll see if it works. I don't think it will. The manufacturer doesn't say that it will, but let's try it. So I've got my piece of material there in light burn. I've taken a picture of it. We can see what's going on. Let's put some text in here. Bexhill West. Probably can't see that. Let's make it a bit bigger. Let's choose my favourite typeface. And we'll rotate it sideways. No, we won't, because that's going to take longer to engrave. We'll do it like that, and we'll squeeze it into this top corner, and we'll draw a little box around it. I'm not going to cut the box yet. Oh, I've stupidly changed the colour of the text. There we go. So I'm going to try engraving that. I've got no idea what settings to use for this. Let's try, I don't want to go too aggressive. Let's leave it on 80% power, and I'm going to take a guess at 400 millimeters a minute. No, I'm not. I'm going to be far less cautious. Let's go 3000, see what it does first of all. So click OK and frame, and wish me luck, we'll start. And there's the outcome. I'll put a still image up on the screen because it'll probably be easier to see. It's not engraved the surface, it has marked it, it's marked it quite nicely, but the heat has caused the brass to distort. Do I think brass is a useful material for a laser cutter? No, not this one, but there you go. A fibre laser is what we really want, but I'll stick a still picture up, you can see what's what. So if you're still watching, thank you very much indeed, and well done. Again, apologies that the project that I kind of promised to be in this video isn't yet complete, but hopefully you've got a little flavour there of some of the testing I've been doing just to sort of dial that machine in. But really, I guess the question is, what have I learned from doing all those tests? Well, I certainly can see no disadvantage to having the extra power. It's quite simply amazing. There have been concerns that the Falcon 2 achieves the different power settings by switching off LEDs, and some people have commented to me that that's going to lead to a premature wear of those LEDs that are on all of the time. So I was keen to see, could we replicate the quality of the cuts at low power with the full 60 watts dialed down, so all the LEDs on, and dialed down in the software? And yes, certainly you can, and as you've seen in the examples I've shown you in the video, the quality of the cut is exactly the same. Now if we run at 60 watts but dialed down through software, we do still have a wider kerf, and that might be an issue for some people. And at first I was thinking to myself, you know, it's definitely more precise on the lower power settings. But of course, within a piece of software like Lightburn, we can offset the kerf within the software. We can make the laser kind of cut outside of our line to mitigate the effects of a slightly wider kerf. So to me, all of this seems to suggest that the 60 watt machine, particularly with the controls that are available in pieces of software like Lightburn or Laser GBRL, it makes it a very, very versatile machine indeed. And I think that probably for, if this was my daily machine, probably for 95% of all the work I do, I would just leave it in the 60 watt setting and just turn it down through software. Now we haven't even looked at the 1.6 watt laser head that comes with the machine yet, and we will get into that next time when we look at this project. When you're used to using 60 watts, 1.6 watts seems daft, crazy. Why do they even include it? I've had one or two ideas that I think might really suit having that super low power, and I've thought of one or two more tests and bits and pieces that we can make for this that would really take advantage of that low power. So we'll get into that more fully next time. Anyway, until then, thank you very much indeed for watching, and I'll see you next time. Cheerio.